So I'm trying to encourage you, Mike, to give it a shot and see if you can build a file system in Floyd 3. But I don't have specific directions on the RAID or anything. So I'm going to demo it. Okay, so RAID. Talk about RAID levels, and basically I want to get into the configuration and how they're configured. So, RAID, redundant array of independent or inexpensive disks. Okay, we have several levels of, we use the word topology to say how these spindles or independent disks are put together. RAID 0 is striping, or what we might call JBOD, just a bunch of disks. RAID 1 is mirroring. RAID 1 will have performance impact on writes. People were getting burned because they were doing I/O tests on the root device for a UV, and the root device is mirrored. So there is a degradation there. They had to get to a drive that wasn't in a mirror situation. RAID 3 you don't see very much anymore. Everything is basically RAID 5. We used to have Clarion drives that were RAID 3 for large sequential video market like a video stream from a satellite. We also have combinations where we have a RAID 01 and a RAID 10. I really don't use RAID 01s. I'll explain the difference in the next module. The main thing is maintenance. And resyncing the drive. With a RAID 01, I'm going to stripe and then mirror. I kind of have the wording backwards here, actually. So RAID 01, we build the stripe, and then we mirror them. So if I have 8 drives that I stripe and then mirror, if a drive goes down, I've got to detach the entire mirror, which are 8 drives, and then when I reattach it, all 8 drives will have to get resynced or repopulated, revived. If I go RAID 10, then I'm mirroring individual drives and then striping the mirrors together. So the terminology is kind of correct here, but I'm saying I build my stripe and then mirror them, so I've mirrored stripes. Or I've striped a mirror. Now the advantage of striping the mirror is when I detach one of the objects, I only have one drive that's the mirror that I have to detach. And when I reattach it and revive it or resync it, I only have one drive to resync rather than the entire stripe group. We also have systems that are now into a RAID 6 that have 2 parity drives. Now when you're talking about friendly, well-formed I/O and stripe widths, you do not include the parity drives in them. So real quickly here, RAID 0, just a bunch of disks. This is a bandwidth capacity. As I'm striping, my bandwidth is going up, but my disk drives are the same and the latency is the same. In fact, you're kind of losing latency because all the drives kind of get locked together and behave as a single drive. And you want the stripe width to match the request size. Particularly when you're doing striping, you're really talking about direct I/O. Which is also referred to as DMA. That's a bandwidth choice. Again, be crossover aware. As I'm adding drives and striping, my bandwidth is going up, but that's not going to help me for a home directory. I do not want to see a home directory that's 128 drives wide. My VI Hello Mom is not going to perform well there. No error recovery with 0, so we stick it with a 1. So here we're just showing a stripe where I've got block 1, 2, 3, 4, or if I'm doing file striping, I may have stripe unit chunks going round robin. I need to come back to this later. This is more of a JBOD. The IOPS are round robin. Whereas here, file striping, the IOP is split up and done in parallel. a lot of the systems I see nowadays, they've got their stripe units so large that they're really doing JBOD and spreading IOPS around them rather than taking a single IOP and spreading it across the stripe group. Let me come back to that later. So advantages: most flexible, cheap if you're not mirrored, best for lots of little IOPS. Disadvantages: no recovery, probably no controller. XVM striping means more mainframe CPU usage. We don't want to have XVM do all the logical to physical mappings. RAID 1, called mirror or plexing, no performance advantage, no bandwidth improvement, possible latency improvement if one of the mirrors is faster. Now the OS still has to mark the IO done on the first mirror done. And there are different read policies on how I rotate between the plexes or the mirrors. Again, used for reliability, often in a combination with 0. However, our root disks on VUV are just RAID 1, and they are done RAID 1 at the LSI Prom level versus an MD, an LVM, or an XVM RAID, or LSI RAID controller. Again, RAID 10 is striped mirrors rather than mirrored stripes. So here I'm showing block 1, block 2, and then a redundant copy. With XVM, we can have up to 8 copies. Of course, that takes a lot more disk space. Most people are not doing this. They have gone to a RAID 5. And RAID 5 is a compromise between price, performance, reliability, and bandwidth, but not for latency. So, RAID 01, striped and mirrored combination, twice as many disks needed. For bandwidth, it acts like a parallel set of disks. They act like a single drive. But for lots of little IOPS, they become more independent. And RAID 01 is often referred to as better for high I/O request concurrency. How many I/O streams am I doing? So here's just a RAID 01. So we're striping across 4 drives, and we have a redundant copy of it. Again, I would build these. I would build that, build that, build that, build that, and then stripe them together, or mirror them together. I'm sorry, stripe them together. Build the 4 mirror objects and then put them together as a stripe. And then if one drive fails, I detach it. When I reattach the new drive, I really only have to revive the one drive. I have less overhead in maintaining it. So RAID 01, more flexible. You might have a TempFS that might get mirrored. I don't see that anymore. So you have error recovery from bad media. RAID 01, RAID 5 do not protect against RM or things like that. That's what backup is for. This is for platters that have bad media. And mirror priority options, the order of the spindles can have a, how do I do it, round robin, that sort of thing. Disadvantage is twice the disk space, so it's going to be more expensive. So RAID 5 is cheaper. You get more disk space available. RAID 3, parity bit instead of a duplicate copy. IOPS act as a single drive, but again, a read, write, write would be real bad. Again, nobody is really, we always got external logs off these things, but nobody's really doing a RAID 3 anymore. So with RAID 3, the RAID controller chunks up our data into segment size. And again, that segment size is configurable on the RAID controller. And then there is a 5th drive for the parity. So when I talk about stripe width, this would be a 4 plus 1. I used to see people do a 7 plus 1. That's just for convenience, because you may have only so many drives in a tray. But I would rather have the stripe width, the number of spindles, a whole number multiple power of 2. So 2, 4, 8, 16, 32. I'm not going to go 12. I'm not going to go 11. I'm not going to go 3. And that's for a performance advantage. But again, if my analysis says I'm not doing any I/O, and SAR-D says I'm never waiting on I/O, and I don't have any I/O wait time going, I don't care. But if I do see problems, then I've got to make it efficient. And I/O in the I/O path, powers of 2 are efficient. A 3 plus 1 is not going to be as efficient as a 4 plus 1. because 3 plus 1, the 3, won't hit a power of 2. You got to be in a power of 2 to get the best. Again, if I have I'm going to show here, if I have an IO buffer here, and I only fill it up a portion of the way, then I'm going to end up wasting potential bandwidth. I want this fire bucket to be a power of 2 hole-friendly numbers of the 4K, 16K, 32, 64, 128, 256, 512. Those are well-formed hole-friendly numbers and powers of 2. But I want my RAID stripe width to be a power of 2 as well. Anyway, that was a RAID 3. I'm going to skip over this. RAID 5 rotates the parity bit around the drives, a 4 plus 1 example, but we don't have a single parity drive. It's spread across them. Now I want to check to see what our segment size is. That is configurable. And there is a profile that will give this information. Now with RAID 5, bandwidth acts as a parallel set of disks when it has a small stripe size. And IOPS act like independent disks. But again, a read, write can make it act like a single drive. RAID 5 is terrible for short writes like online transaction processing because of what's called the write penalty generating the parity. The Oracle database engine at USPS, the Oracle partitions were configured for latency and they were not striped. But the checkpoint file system for times 10 was meant for large sequential I/O, and that was striped. Not intended for better performance, but it is a space write parity distribution compromise. And again, if you are a hot journal, if XFS statistics show you that your journal is hot and the drive is always busy, then you can go to an external log. And if you look, both of you, I'd like you to bring up SME GUI on Floyd 3, and they are built as a RAID 5 with another LUN for an external log. I have not mounted that file system yet, but the RAID right now is built 5 LUNs, 4 that are RAID 5 and 1 that is RAID 0. RAID 6 has 2 parity drives, which allows, that should be TWO. That should be a 2. 2 drives can fail, and then you can activate a hot spare. With RAID 5, only 1 drive can fail. With RAID 6, 2 drives can fail. So here we're just trying to show a RAID 5 where the parity is distributed across the drives. Again, with RAID 3, we were always hitting the 5th drive. But you still consider the stripe width to be the 4. You do not count the parity drive. So this is a 4 plus 1. I might have a 4 plus 2 plus 2. 4 data drives, 2 parity drives, and 2 spare drives. And then here's a RAID 6, and they call that other thing a queue. But here we're spreading parity and a backup of the parity spread across 6 drives rather than 5. So advantages, the write penalty is distributed across the spindles. It's cheaper than mirroring because you're not doing twice the disk space. You do still have write penalties. It is the best compromise between price, capacity, reliability, and performance. But it can be bad for lots of little IOPS. Typically things are less than 256 kbyte. If I'm doing VI Hello Mom, for example. And then most RAID controllers have improved their firmware to handle small I/O, random I/O. And some will actually have the RAID configured and meant for random I/O. So I talked about crossover, but when they're looking at the drive, they will characterize the drive saying this one's good for video or this one's good for database. So again, know my characteristics. Online transaction processing, lots of little. Metadata, or sequential. So if I were to match these actually, bandwidth was this one over here. Metadata was the news and mail server, and latency was for transaction processing. Know my I/O patterns, large versus small request sizes. Am I doing lots of little or a few large? Am I reading more than writing or writing more than reading? Am I doing sequential or random I/O? Again, that was strace with an lseek, looking for the seek commands. You have to worry about append, rewind, and truncates. And also, again, a write-rewrite means regenerating parity, and that can have issues. And you can get into the flush, dirty underscore background underscore ratio, and dirty underscore expire underscore centiseconds. We are going to talk about those tomorrow. So I could increase those, preventing the first write from completing, such that when I do the second write, I've not already initiated the I/O for the first write, and I can cancel the first write. Also relevant is concurrency. Am I single-threaded in one stream, like a video stream coming down from a satellite? Or do I have independent streams, multiple streams, lots of different people reading different video files? Or are these tightly coupled I/O streams? Independent single are not locked together. But if I got pthreads or any one of these doing concurrent I/O, tightly coupled, that's even more severe for concurrency. Again, I want to know if I'm cache buffered, direct, or raw. And then synchronous versus asynchronous. So again, the more I know this information, the more relevant my configuration decisions are. I was trying to teach this to USPS, and they had the same issue coming from LSI. When LSI came in, they told LSI, I have no idea what my I/O characteristics were like. Again, some of these people that were doing that were former SGI people as well, so we're all pretty much on the same page. And again, I do have the training manual, the class for the LSI tuning on my website. And everything that I'm talking about is consistent with what they are talking about. I'm constantly trying to make sure that technology hasn't changed some of this stuff. So, unfortunately, you're probably black and white. This slide is 10 years old. I have not gotten anybody to regenerate this data. What we've got here are 3 different RAID levels, 10, 5, and 3. Up here are the reads, down here are the writes. And I'm doing random I/O single thread, random I/O lots of threads, sequential I/O one thread, and sequential I/O lots of threads. And then down here is the request size. Also, I may have write cache on or off. So green is good, red is bad. So if you look at this, if I have one single thread, RAID 10 is better than RAID 3. RAID 5 is a little bit better. But notice RAID 3 is terrible for lots of little I/Os. RAID 5 for random many and RAID 5 for sequential many, there is a slight degradation. Down here when I'm doing writes, RAID 3 on writes is the worst because of write parity. And then when I'm doing random I/O, I also have poor quality for random I/O to writing randoms to a RAID 5. And here again, RAID 10 is the better performer. So in a lots of little I/O situation, configuring your file system to handle little I/Os has an advantage. Now at the other end of the spectrum, when I get to a 2 megabyte request, note that RAID 3 is the best, RAID 5 is in between. And notice right here, random many, RAID 01 is not so good. Now this is, when I first saw this, this was a perfect example of describing my crossover. So knowing if I'm doing lots of little or a few large, knowing if they're sequential or random, helps me make some decisions about the best RAID level. But again, most people are going RAID 5 for simplicity and reliability. Now this Oracle database across the street from me for USPS, they went RAID 0, RAID 01 for their database market, for their online transaction processing side. But then they went RAID 5 for their checkpoint directories. I'm going to let you think about that, and we'll come back to that later. Command tag queuing. I mentioned the TIB earlier. This is the TIB that you use to figure out for your situation how to, or what value to set the CTQ for. So again, the Pro, we're partial burial of command overhead and seek latency. Basically, we're queuing these things up on the spindle so that the spindle can stay busy. And the spindle does have a sort algorithm too, so if there's multiple IOPS queued up on the spindle or the RAID controller, then they can sort them. If commands are pre-sorted, like from the elevator, the sorting algorithm may add significant overhead. Now, we're actually turning off the sorting algorithm on the OS at the elevator and using the RAID sorting algorithm nowadays. Again, part of CTQ was if my channels get saturated. So what I talked about earlier is trying to get a command through the device when there is a hole of opportunity, when there's a window in the interface that I can punch this command through, but keep them queued up on the other side of the interface so that the spindle can keep busy. Bottom line, you have to figure out the max for the controller. What's the maximum number of IOPS that the controller can keep track of? 255 was the older one. Actually, it was 256. This TIB will tell you for your RAID controller and your firmware level what the maximum is that that controller can keep track of. You then divide by the number of LUNs such that basically every LUN has an equal CTQ that will not add up to more than the max. That's the bottom line of what you're trying to do. Get an equal command tag queuing length that when it adds up to everything that that controller sees does not exceed what the controller can keep track of. Otherwise, you can get controller errors and stuff if it loses track of these CTQs. But 256 was the older controller. Look at this technical information bulletin for more details. RAID inventory. This is the key one. Storage, show storage array. There is lscsi-t. And then there are individual commands to look at things, but show storage array will give me everything. This is my profile. Now, if you log into Floyd 3, I already have a profile report in /temp. Now, you can do it from command line or you can do it from the GUI. So, storage array, commands that run all inventory shows the volume groups. So these volume groups, which drives are in a group, is basically a LUN. That is going to be a LUN presented to the OS, to the kernel. So you can find out which drives are in the group, what the RAID level is, and what the segment size is times the number of spindles. Also, the controller has configuration, so we can control the cache, control how the caches are mirrored and battery backup, and determine which volume group is using which controller. Also in the inventory, knowing the disk, what the spindle model is, and sometimes you may want to know what the geometry of the disk is, because you may want to do I/O in track sizes. So here's a show all controllers. This is two controllers. I got the firmware level. I got the model of the controller. I don't spend enough time like the other people do to know exactly which device that controller is for. The product ID here has been marked as an IS500. Carlos, do you happen to know what a 3992 actually is? I don't know if that's a 5000 or something.
Yeah, I don't.
Yeah, someone like Mitch Mueller that left SGI would know exactly what device that is. I don't always trust the product ID. This is what's going to show up in LSCSI. Vendor, data manufacturer. Again, here now is my cache statistics. So this one has a 735 data cache, and the RAID controller itself is using 289 megabyte for its own operating system. This was done by command line, and did a show array profile again. 2 controllers. I've got 1 volume group. It's configured as a RAID 6. Looks like there are 2 volumes. Number of drives, it looks like it found 16 slots in the tray, or trays. And I don't really care about a lot of this stuff right now. Number of drives, I've got 16 drives here. And then to show all drives, so this drive is a 465 gigabyte drive. It's a SATA drive. It's from Seagate. ST drives are Seagate's. HD or Hitachi, and there's an MA or something like that for Maxtor drives. Also see the firmware level. This is spinning slow. Again, my SAS drives nowadays are at 15,000 RPM. And here's the worldwide name for it, by the way. Anything else that I care about in here? Not really. Then looking at the channel, so I can see the drives that are attached to this controller, tray number, stuff like that. Not really caring about anything here. We can see what the fabric is rated at, the lanes. And then here's my volume. So I've got a volume here known as Floyd 0. There's the capacity. This one is a RAID 0. And again, it's SATA drives. Let's see, I don't know if I care about anything there. Segment size, 128K. Maximum could go to 2 meg. Write cache, read cache is enabled, but especially write cache is enabled with mirroring. Now I cannot see here how many drives, it's a RAID 0. I cannot see how many drives are in this from this right now. Do I see? Nothing really there. Let me go on to the next one. Oh, I guess I don't have it. So there would be another one for the volume group, and in this case, let's just say it was 4 spindles. It was RAID 0, so there's not a 5th parity drive. So that would give me a 512 K-byte request that would be optimal for this device. Now there are 2 ways of looking at this. You can figure out what is the optimum file system configuration for an I.O. request, or what is an optimum I.O. request for a given file system. So here I'm saying the optimal request for this file system, assuming it was 4 spindles, would be 4 times 2048, or 512K. And that's in powers of 10. And you'd really want it in powers of 2. Get it exact. This is KB, not KIB. So there is a GUI. This is what I wanted you to bring up on. I have 2 RAIDs. One is on NAS server and one is on Floyd 3. So I was going to have Carlos, I was going to have you look at the NAS server RAID to figure out how it's built. And Mike, I was going to have you play with the RAID on Floyd 3. Now it's up to you, Mike, whether you want to actually tear it apart and redo it. So I brought up the SME GUI, picked on Summary so I can see 2 controllers, 16 drives, volume groups and stuff. And I got to warn both of you, the older GUIs changed this under troubleshooting. You don't collect drive data as much anymore. Now it's capture state information. That's the one that you typically want. There's also one under here to get profile. So this will generate an ASCII file that you can send to support staff. And I want to do that on my system. And then you also have to map these LUNs to particular hosts. So NAS server and Floyd 3 have a RAID on them. So here, let's see, can't really see this. This looks like the older GUI, by the way. You got to be careful. This GUI was for the TP9400. I have a 9400 on NAS server, but I got a 5000 on Floyd 3. And I can't run the newer SME GUI on the older firmware of the 9400. So this, I got to be a little careful here. This is kind of old. And then here I was actually able to go in and click and see my drives, click on a particular drive, and then it would tell me about the drive. And again, these were SATA drives. If I scroll down, the model is in there, things of that sort. But again, this is the older GUI. You've got to be a little bit careful here. There's also a Performance GUI. So this is basically telling me the number of IOPS and cache behaviors and bandwidth type of information. This is what a lot of sites will use for a quality of service. I've seen sites that use this for their benchmark acceptance to say that they're getting the bandwidth they accept. Not what SAR is giving, but what the RAID controller is giving. This is garbage to me. There is the SSMC web interface. What I don't like is it is using MIB powers of 2 for bandwidth. Nobody else does that. You're not going to be able to correlate those numbers to other things because these are in powers of 2 versus powers of 10. And it is a licensed product, but it is available there. SMC for IS, I think is what it's called. And you can also get in to look at individual drive statistics. Here's the key one that I was trying to get to. VD show, or the newer ones, and I haven't done this lately, EVF show volume. So this is telling me what the RAID controller is seeing. So right here is segment size. And in this case, it looks like a majority of my requests, reads and writes, are smaller than the segment size of the controller. But I did get some large writes as well. Total number of operations, cache hits, and then a cache hit rate. Average block size, and then again, I do, the workbook should have, the next page describes each of these statistics, what each of them means. I'm only interested in characterizing to see what are the request sizes that my RAID is seeing. If I've got the RAID set up to large segment size, then I want to go back to dev-attr.conf and up the max sector kbyte, for a DMA that matches the stripe width. We also get statistics on the cache hits, misses, and stuff like that. So this will tell me in profile and characterize the nature of the IOPS that the RAID controller is getting. I haven't used this. I think this is a DDN type of command. There's a mon command. I'm just letting you know it's there. Here is SG mode tool, and in here I can spot about write cache enabled or not. When you're into the Prom on a Spindle, they call it a page. There are different mode pages. And I am displaying mode page 8 here, which is giving me things like the write cache enabled is a big one. You can also get into things like how many pages. Here's read aheads. Here we are. Number of cache segments, which is basically number of pages that you're going to break the cache into. And we're talking about the cache that's on the Spindle, not the cache that's on the RAID controller. This is for Spindle Prom. We used to have a tool on IRIX that would go out and set all the Spindle Proms to the same for a video market and would make page sizes of the cache segment size real big and few of them. In other words, converted the Spindle to a bandwidth type of Spindle for video market. Here's another DDN statistic just showing me what's going on for bandwidth, IOPS, and cache behaviors. RAID settings, some of the global things, how often we flush the cache, it's like 10 seconds by default. Media scan can impact things. Write cache, whether that's on or off. Read cache, whether that's on or off. Command tag queuing. And again, the segment size times the number of spindles. So I kind of had for a lab whether you can explain RAID levels, talk about the differences, a brief idea of what the problem is. There's so many disk products, we can't cover them here. Understand command tag queuing, and I want to go into SME GUI. And then here's what we were just talking about, draw out the IO chain and understand the statistics from VD show and the Spindle Prom settings. Let me go to demo. You should be able to see my desktop now. Since I'm on Windows, I need to get an X11 environment going. I want to go to Floyd 3 right now. But again, Carlos, you can look at NAS-server as well and figure out how NAS-server failed to connect. I probably know why. Let me, well, I've already got one here. SSH to Floyd. I'm sorry?
There's a password on there now, SGI.
Uh-huh.
Because I'm never sure about that VNC stuff, so I always do VNC server, and then it always prompts you for a password.
Yep, but I don't have VNC server on my Windows system. Let me see what I can do here. But let me just do a check config, VNC. So that's showing that it's on. PS-E. Ref for XINetD. VNC server won't be running unless I actually connect into the network socket. Now this is where I get into a catch-22. How did you put your password on the system, Mike? Command line or GUI?
Which password to which? To the VNC server?
Called Vino Preferences. Of course, no. I don't have X. And if you're on a desktop, the Vino Preferences can set the passwords and access control to the desktop through a GUI, but it's under Control Center, but not under YAST. And I can point a camera at my SLES system. But I was just wondering, so Vino Preferences, and there's a VNC password command and stuff like that.
Yeah, well, all I done was put the password in at VNC server, that was all, and then used that display that it gave me back as my VNC viewer.
Right. Well, let me just see if I can still get connected here. And I am connected here now. Oh, I went to Floyd 2 instead of Floyd 3. That's okay for right now. I'm going to log in as root. If I ever get there. Not responding to me well. ROOT, there we are.
Oh, you're on Floyd 2 there.
Yeah, I know.
Oh.
I'm just going to avoid it. I've got it on Floyd 2 as well. It just won't be in band. It will only be out of band. In band is when I'm actually going through the HBAs. Oh, wait a second. I'll only be out of band, not in band on the system. But let me just see what I can do.
Well, I've still got my VNC viewer up on Floyd 3, so for me it still works.
Yeah, that's fine. Let me see if I can get to it. I might not be able to get to it because you have it too. I agree with what you're saying. Let's see what we have for options.
No, I think I'm using display 2 or 3 actually.
Sure. Okay. Let me try.
Okay. Yeah, I'm using Floyd 3 through display 3.
There we are.
They both got killed earlier in the memory killer, in the out of memory killers, I think. So there was 1 and 2 was hanging about.
Yeah, understood.
Yeah.
So I've got 3 going here, Carlos, and I'm not getting into the details here.
Right.
This is probably your desktop there?
I'm showing, yes, exactly.
And it is a funny desktop.
It is.
We're missing some of the window manager stuff.
Yeah,
so I'm going to kill this here.
Default though, isn't it? I never bother much with them because I never use them, but you always get that as default.
Yes. So I did load, again, we had problems at the beginning of the week, and I loaded the GNOME desktop stuff, but we don't have a complete, there are RPMs missing. But I should be okay here. Now, some of these are not actually connected anymore. They were known in the database. We moved this from the training SAN that the hardware trainers Mitch Mueller used to our own private DMZ. It was not on the DMZ before. So there are some arrays in there that were on the SAN that we were on before but are not there anymore. But it still has them. And I was not able to remove them. But the one that we do have here is storageArray. Well, unresponsive, let's see what happens here. And I'm not sure about the ability to get to the controller. Not looking good right now. And it does say it's unresponsive here too. And I am on Floyd 3. So I may have to look at this offline or something. I can't get to anything there. There is a manual for this guide. And again, I don't know, without being physically there, what's going on with the device right now.
Try a rediscovery.
Yeah, I was going to do that next. Martin had changed the IP addresses of the controller last week. So it's out-of-band management. Oh, I need the IP address here. Hang on a second. I'm hoping that Jim Martin used, oh, wrong one still. So let me try these two IPs. Well, it's not letting me paste into it, but 192 dot. Here I ran it last night and got an inventory, 192.48.186.134, and then 135, 192.48.136.135. And this would be out of band management. Let's see what happens here now. In-band would be when it's actually using the HBA. So it looks like it discovered it now as an out-of-band. Let's see what happened here. So there, let's see if we can get to it now. I'm still having problems with it because of the out-of-band not working or something. I don't spend a whole lot of time in this area. Now, if I go under here, though, once I've got it selected, well, let me try a different one. Same concept, but let me just go to a different one here, NAS- server. Now this is for a TP9400. So I've got an icon here already. Close. I have one UV storage that's here. Let's see if I can get to it. And it did find this one. This is what was not happening on the other one. I do have some problems in this area. So this is the storage that's on NAS-server. And I see I've got 6 volume groups. 1, 2, 3, 4, 5 of them are RAID 5, and 1 of them is RAID 1. Notice there are some problems here. We've got some things that are showing drives that have gone offline. That's why I really don't use this RAID anymore, because it's hard to keep this thing running anymore. If I click on one of these groups, I can see which drives. So this is a RAID 5, 2 plus 1. Another RAID 5, and I can see the actual drives that are in that particular group. These were small drives, so they look like they're about 15 gig, 20 gig drives in this example. Let's see if we can pick one here. Properties, and then I can see it's a 16 gig drive. Seagate ST318451FC. Okay, and then under storage array, you can locate things. I don't care about that. Save the configuration. Here's the monitor performance one, so we can see the I/O. I'm going to save this for tomorrow. Change. So here's where we can go in and change cache settings, for example. So this is flushing after 80 seconds, or I'm sorry, 80%. If we get, that's an 80% ratio. And the cache block size here, by the way, is 16K. The example we had before was 32K. Again, this is an older device. Now, let's see if I can spot here. If I go under Advanced, Capture State Information, and then I can type in yes, and hit OK. It's going to ask me where I want to save it. I'm just going to save it in root / TP9400-profile. Start. And now it's generating an inventory. Now you can do this from command line as well. Let me just leave that alone for now. If I go back to Floyd 3, last night, just to test it, did generate an isbottom.dmp. We're generating that same thing for the 9400, but let's take a look at this thing. So this is a verbose report. I'm just going to page through, don't care about this stuff. This doesn't look like what I really want. Here are the EF show vol information, the volume attributes. And there are the statistics I was talking about. And again, this is a little different. This is a 5000, so the reports are a little bit different. And here again is the write statistics. There wasn't anything going on there. Here we got some of the performance statistics. Clustering means I was able to group a whole bunch of pages together into a single write. Volume, reads, writes. Back up. So here, what I have here, I have there are 5 volume groups here. 4 of them are RAID 5 that are 3 wide. So I went 2 plus 1. And I didn't have enough drives to keep on going. I needed enough LUNs to be able to use XVM on top of it. So this is all the information that would have been available through the GUI as well, and is being snapshotted on the other thing. And I was looking for segment size. So it looks like the segment size is 256 blocks. So let me bring up a calculator here.
512.
XCalc is all I'm going to use. So I take the 256 blocks times 512 times what?
1024?
No, I've got 2 devices in the LUN group. So my segment size in bytes is 131,072, but I've got 2 plus 1 as a topology. So the optimal request size for this would be 2 times the segment size, which is a 256, and actually 262,144. So these LUNs are optimally designed for a 264 or 262,144 request size to each LUN. And that's what we would like to see from top disk, from SAR-D, and XVM to match that 262,144. I'm going to divide by 512 to get this back into blocks. So I need XVM to have a stripe unit size of 512. So a 512 block size from XVM will put what we have, a 256 megabyte request split across the 2 drives into a 128 kbyte request per drive. And then we'd also like to make sure the Spindle is friendly to a 128 kbyte request, but most people don't do that. Let me go off to a NAS-server. SGI is the password there. So here's the profile that I just got. Let's take a look at that one real quickly. Same sort of thing. Let's see. Let's find out the segment size here. $128 blocks in this one versus 256 on the last one. And this is a 2 plus 1 RAID. 5. Okay? So for this one, 128 blocks is basically half of what we had before. So this one's optimally for a 128 kbyte request that would get split into 264 kbyte chunks and spread across the 2 drives. I don't know if you're following me. So I'm taking this times this to figure out what my stripe width is of this LUN. Now also, I don't know if we have our LUN numbers here. There's my cache block size is 16 kbyte chunks in this example. In fact, we can see the stripe size was 256 blocks, or 128 kbyte. Let me see if I can get volume. I was actually trying to find out more about the drives that are in there. Here we do have the location of the particular drives that are part of that stripe group. And again, when I was on the GUI, I was able to click on it to see which drive's in the tray. And I'm also trying to find the LUN number. Well, let's break out of here for a second. With an LS-SCSI, so here is on NAS-server, and the LUN number when I assign them is 0 through 5, and we ignore 31. So I've got 1, 2, 3, 4, 5, 6 LUNs being presented. And from the other report, 5 of them were a 2 plus 1, it looked like, and 1 of them was a RAID 0. But I'm not sure of that right now. Let me go to Floyd for a second. So people, when they assign LUN numbers, when you're in there actually building the LUNs, they will pick LUN number ranges in a scheme to make it easier to find them. So again, LUN 10 to 14 is what's coming off that 5,000 that we've got. And then I also have alternative paths. two different ways to it. LSPCI, let's grep for LSI. So there's my two fiber channel RAID controllers that I have. Topology -IO and also -AFF for affinity. Now it tells me that this is on CPU 16 and CPU 17. And again, this is that magma chassis attachment. And I also see the interrupt number that these devices are coming in on, IRQ 48 and 58. If I do a more on /proc/interrupts, and it's kind of hard to see here, 8, here's 48. I'm going to come back to this in a minute here. So right there, 48 is known as this IOC 0. Now, I'm going to go back to there's a -V option here, and this will tell me exactly how many interrupts are coming in. So those interrupts are coming in on CPU 16 and CPU 17. However, have to be careful here. There should be an IRQ balancer. It doesn't look like it's installed. These are the interrupt handlers that are actually doing it for each CPU. I don't see any interrupt handler time there right now. The other thing is ints. There is an int stats command now to look at proc interrupts. I type in an H, and I got my help. And I'm going to toggle between since boot versus incremental. So I'm going to hit a T, and now these are the number of interrupts coming in. This is your clock interrupt, by the way, what's called a jiffy. We're getting minor clock ticks, or jiffies, 250 times a second. Now, if I use and there's my IOC 48 and 58, if I use the left, right, or up or down arrows, I can go down in the display, go up in the display, or go to the right. And again, I'm not seeing any interrupts coming in on those controllers right now. And again, you do want to know where these controllers are coming in on, but for some reason, the SGI IRQ balancer isn't loaded on this system. I'm going to check on that later. Again, I built these systems from a restore AutoYAS file. But the purpose of the IRQ balancer is to spread the IO interrupts across the socket so that one CPU isn't handling all the interrupts. Trying to spread the load across the socket. Okay, now HWinfo --disk, let's grep. And by the way, I do not have failover configured on this system yet. I haven't run the make failover script yet. And this can get real verbose. In fact, I'm probably going to get more lines than I want. I should have done device files. Device files. Let me try that one. There we are. So now for each of these devices, I can see SDL. Here's the major minor number for it. Here's the by ID. Here's the by path and the LUN number. So I had LUN 10, 11, 12, 13. Let's see here. LUN 13 here. And LUN 13 here. So SDI and SDD appear to be the same device. Do they have the same 5085, LUN 13, and down here 5085, they have the same ID and everything. And then we've got this LUN number. This, by the way, is different than prior releases. This first time I'm looking at this on SLUS 11 SP2. So the HW info report has changed a little bit. I wonder if that's going to create a problem for me. I've got a little script here. I'm in my root bin directory. And I've got a script called get disk farm. I just want to see if it works. Oops. I think I commented it out. Oh. This isn't the right one. Let me leave that alone for now. But what it was trying to do was list by ID all the different names for the same device and sort them. I've added that into System Info Gather. Let me see if I can find one here. So looking at the system, I've just jumped into the latest System Info Gather report. It found 20 devices. LSCSI. We subtract out these. I'm not sure that I still got 20, 6, 12. I've only got 14 there, so I'm not sure about that report right now, but I'm going to move on. And then I'm listing what the devices were that I saw. Then I've got the allSCSI output. So here I can see the LUN numbers. Here's my 10, 11, 12, 13, 14. And then 10, 11, 12, 13, 14 again. The only difference will be the path. Then I'm doing allSCSI-H, allSCSI-T to give the target address. Topology for the affinity information that we just talked about. Proc partitions to get major, minor numbers. Oh, and by the way, notice now we have what's called Path Manager. This is new in last fall's XVM. Parted information. Oh, here's what I was looking for. So this is a script that I integrated into System Info Gather that Get Disk Farm started this. So I'm giving the allSCSI by ID. I'm giving the major, minor number. I'm giving the by ID serial number, and then the name, and then the path, and then the name and the path. So here I've got 4 paths to this. SDD, SDM, SDK, and SDB. I'm not sure that's right. Oh, that's right. SDA and SDB are not my root on this system. The RAID is being discovered before root. So that's why we've got SDB. So those are 4 paths to the same LUN. So now I know all 4 of those are the same RAID LUN. And that RAID LUN, or in this case, the RAID LUN is 10, 11, 12, 13. And that's what I was trying to generate here. A mapping to say, and then here's my root devices, SDS and SDT. Now this is not the way the system currently is. This had other devices on it, other things that were on the SAN when I generated this report a couple weeks ago. By the way, when you're in this report now, what's best to do is a /12345 space, and you can basically move on to the next header for each of the report options. So it makes it easier to dig through this file. And if I grep, I can see all the different outputs that are in that particular report. So I've done a lot to try to improve the usability, particularly in large CPU systems, to see what all the different reports are. We were just in there, just device by names, by ID, so that I can map an ID and a name back and forth. I think we should take a break here. Hang on a second. Yeah, let's take a break here. I know I'm pushing late. I needed to cover XVM a little bit. Okay? Can we take a 15-minute break, come back at 1/2 past the hour? and then I'll do the XVM lecture, and then we're done for the day. Does that work?
Okay.
So we'll see you in 15 minutes.